IEC 61024 is an international standard developed by the International Electrotechnical Commission that provides guidelines for the design, installation, and maintenance of lightning protection systems for structures. The goal of IEC 61024 is to minimize the risk of damage to people, property, and infrastructure from lightning strikes. IEC 61024 applies to all structures, including buildings, industrial facilities, monuments, and other structures that need protection against lightning. It covers both external and internal lightning protection measures. A lightning protection system, or LPS, is a system of components designed to intercept, conduct, and dissipate lightning energy safely into the ground. External protection involves measures taken to intercept lightning strikes before they reach the structure, such as lightning rods and air terminals. Internal protection involves measures taken to protect the interior of the structure from lightning-induced surges and overvoltages, such as surge arresters and shielding. IEC 61024 requires a risk assessment to determine the appropriate level of lightning protection for a given structure. Factors considered include the lightning environment, the vulnerability of the structure, and the consequences of failure. IEC 61024 provides detailed guidelines for the design and installation of LPS components. It includes specifications for materials, grounding systems, and testing procedures. The LPS must be integrated into the overall design of the structure to ensure its effectiveness. Regular maintenance and inspection are essential to ensure the continued effectiveness of the LPS. IEC 61024 provides guidelines for periodic inspections and testing of all LPS components. For further information, you can visit the IEC website at Webster. ch/publications/61024. You can also refer to Intertek's Lightning Protection Guide at www.intertek.com/building/lightning protection testing/. NFPA 780, the standard for the installation of lightning protection systems, is available at nfpa.org/codes and standards/all codes and standards/list of codes and standards/detail. Code equals 780. IEC 62.23 is the IEE standard for the protection of structures against lightning, which can be found at standards. IEE.org/IEE/62-23/2012/. It is important to consult with a qualified lightning protection specialist to ensure that the LPS for a specific structure meets the requirements of IEC 61024 and provides the necessary level of protection. When considering lightning protection, understand that it is a comprehensive approach involving several key aspects. Firstly, a thorough risk assessment must be performed. This assessment evaluates factors such as the frequency of lightning strikes in the area, the type of structure, its height, the materials used in its construction, and the potential consequences of a lightning strike. This assessment helps determine the necessary level of protection. Secondly, external lightning protection measures are crucial. These measures aim to intercept a lightning strike and safely conduct the current to the ground. The most common components of an external LPS include air terminals, also known as lightning rods, which are installed on the highest points of the structure. These terminals are designed to attract lightning strikes. Down conductors are heavy gauge wires or cables that connect the air terminals to the grounding system. They provide a low impedance path for the lightning current to flow to the ground. Grounding systems are essential for dissipating the lightning current safely into the earth. They typically consist of ground rods, ground plates, or a ground grid buried in the soil. Thirdly, internal lightning protection is equally important. This type of protection aims to mitigate the effects of lightning surges on electrical and electronic equipment inside the structure. Surge protective devices, or SPDs, are installed at various points in the electrical system to divert surge currents away from sensitive equipment. These devices protect against overvoltages that can damage or destroy electronic components. Shielding involves creating a conductive barrier around sensitive areas or equipment to reduce the impact of electromagnetic fields generated by lightning strikes. Fourthly, proper bonding and grounding are critical throughout the entire lightning protection system. Bonding involves connecting all metallic components of the structure to create a common ground potential. This minimizes the risk of voltage differences and potential arcing. Grounding ensures that the lightning current is safely dissipated into the earth, preventing damage to the structure and its contents. Fifthly, regular inspection and maintenance are necessary to ensure the continued effectiveness of the lightning protection system. Periodic inspection should be conducted to check for any damage or corrosion to the components of the LPS. Testing should be performed to verify the integrity of the grounding system and the proper functioning of surge protective devices. Sixthly, the design and installation of a lightning protection system must comply with relevant standards and regulations, such as IEC 61024, NFPA 780, and IEC 62.23. These standards provide detailed guidelines for the design, installation, and maintenance of LPS components. Seventhly, selecting a qualified lightning protection specialist is essential. A qualified specialist has the knowledge, experience, and expertise to design and install a lightning protection system that meets the specific needs of the structure. They can also provide ongoing maintenance and support to ensure the continued effectiveness of the system. Eighthly, consider the specific requirements of different types of structures. For example, industrial facilities may require more robust lightning protection systems than residential buildings due to the presence of sensitive equipment and hazardous materials. Data centers and telecommunications facilities also require specialized lightning protection measures to ensure the continuity of operations. Ninthly, be aware of the limitations of lightning protection systems. While a properly designed and installed LPS can significantly reduce the risk of lightning damage, it cannot eliminate it completely. Lightning is a powerful force of nature, and there is always a chance that a lightning strike could bypass the protection system. Tenthly, educate occupants about lightning safety. It is important to educate occupants of the structure about the risks of lightning and the safety precautions they should take during a thunderstorm. This includes avoiding contact with electrical appliances, staying away from windows and doors, and seeking shelter in a safe location. In summary, IEC 61024 provides a framework for implementing comprehensive lightning protection measures. By understanding and implementing these concepts, you can significantly reduce the risk of lightning damage and protect people, property, and infrastructure. Remember to consult with qualified professionals to ensure the correct application of these standards for your specific needs. Also, remember that lightning protection is not a one-time investment. It requires ongoing maintenance and updates to remain effective. As technology advances and structures change, lightning protection systems may need to be modified or upgraded to ensure they continue to provide adequate protection. Consider the long-term costs of lightning protection when making decisions about the design and installation of a system. While the initial investment may seem significant, the cost of repairing or replacing damaged equipment or structures due to a lightning strike can be far greater. Moreover, the potential for personal injury or loss of life should always be a primary concern when considering lightning protection. Staying informed about the latest advancements in lightning protection technology is also important. New materials, techniques, and devices are constantly being developed to improve the effectiveness of lightning protection systems. By staying up to date on these advancements, you can ensure that your lightning protection system is using the best available technology. Finally, remember that lightning protection is just one aspect of overall safety. It is important to have a comprehensive safety plan in place that addresses all potential hazards, including lightning, fire, and other natural disasters. A well-rounded safety plan can help protect people and property from a wide range of risks. By taking these factors into consideration, you can make informed decisions about lightning protection and ensure that your structure is adequately protected. Remember to prioritize safety and consult with qualified professionals to ensure the best possible outcome. In the context of IEC 61024, it's also important to understand the different levels of protection that can be implemented. The standard defines several lightning protection levels, each with its own set of requirements for the design and installation of the LPS. The level of protection required depends on the risk assessment, which takes into account factors such as the frequency of lightning strikes, the type of structure, and the potential consequences of a lightning strike. Higher protection levels require more robust and comprehensive lightning protection systems. For example, a structure that is located in an area with a high frequency of lightning strikes and that houses sensitive equipment may require a higher protection level than a residential building in an area with a low frequency of lightning strikes. The selection of the appropriate protection level is a critical decision that should be made in consultation with a qualified lightning protection specialist. The specialist will be able to assess the risks and recommend the protection level that is best suited to the specific needs of the structure. Once the protection level has been selected, the lightning protection system must be designed and installed in accordance with the requirements of IEC 61024. This includes selecting the appropriate components, such as air terminals, down conductors, and grounding systems, and ensuring that they are properly installed and connected. The standard also specifies the minimum requirements for the materials used in the lightning protection system. For example, air terminals and down conductors must be made of corrosion-resistant materials that are capable of withstanding the high currents and voltages associated with lightning strikes. The grounding system must be designed to provide a low impedance path for the lightning current to flow to the ground. This is typically achieved by using multiple ground rods or a ground grid that is buried in the soil. In addition to the external lightning protection system, IEC 61024 also addresses the need for internal lightning protection measures. These measures are designed to protect electrical and electronic equipment inside the structure from lightning-induced surges and overvoltages. Surge protective devices, or SPDs, are installed at various points in the electrical system to divert surge currents away from sensitive equipment. These devices protect against overvoltages that can damage or destroy electronic components. Shielding involves creating a conductive barrier around sensitive areas or equipment to reduce the impact of electromagnetic fields generated by lightning strikes. This can be achieved by using metal enclosures or by installing conductive mesh around the perimeter of the area to be protected. Bonding involves connecting all metallic components of the structure to create a common ground potential. This minimizes the risk of voltage differences and potential arcing. Grounding ensures that the lightning current is safely dissipated into the earth, preventing damage to the structure and its contents. Regular inspection and maintenance are necessary to ensure the continued effectiveness of the lightning protection system. Periodic inspections should be conducted to check for any damage or corrosion to the components of the LPS. Testing should be performed to verify the integrity of the grounding system and the proper functioning of surge protective devices. The results of these inspections and tests should be documented and kept on file for future reference. In summary, IEC 61024 provides a comprehensive framework for the design, installation, and maintenance of lightning protection systems. By following the guidelines in this standard, you can significantly reduce the risk of lightning damage and protect people, property, and infrastructure. Remember to consult with qualified professionals to ensure the correct application of these standards for your specific needs.